Um, Hi, my name is Ludovica Labruna, and I'm the CEO of MagneticTides. We are developing an innovative form of non-invasive brain stimulation for chronic stroke recovery in a tolerable way. There are millions of people in the United States that live with disability due to a stroke. And this disability impaired the quality of their life because they are not able to talk or to walk. The problem is that current chronic stroke treatment, the one that are approved by the FDA, they still have limitation. The standard of care is rehabilitation, but rehabilitation is very slow, and there is a plateau. There are interesting technology like the biofeedback, but those are limited to specific muscle group. And then there are invasive options. They are effective, but they require surgery and they have side effects. And we're talking about a population that is already frustrated by years of chronic disability. So a major unmet need exists for a solution that improves recovery time and outcome in a tolerable way and that directly target the brain. We call it KTMP. KTMP stands for kilohertz transcranial magnetic perturbation. Is a sub-threshold non-invasive brain stimulation method. The key innovation is that we deliver continuous wave magnetic E-field that are kilohertz frequency. When there is a stroke, what happens is that there is an imbalance of the cortical excitability, and there is no correct way for the neural rhythm to work. So a non-invasive brain stimulation method that really can effectively work on the recovery of the stroke is a device that is able to target the area that are relevant, do this in intensity that are significant, they really impact the brain, and has to do it in a continuous way, so they can really target neural rhythm. Right now, magnetic induction method, they only deliver stimulation in a pulsed way. They don't deliver stimulation in a continuous way. We decided to use kilohertz frequency because when you go to kilohertz, given that it is a magnetic induction method, and the E-field is proportional to the frequency, we can have high E-field with the high frequency. This is how KTMP look like. And let's see if we can nail these key parameters. Well, the targeting, it's easy. We have a coil. We can move the coil around in the brain. And by changing the shape of the coil, we can change the focality of the area that we're going to be stimulating. The intensity is the most important part. We are able to deliver at cortical level 8 volts per meter. This is 16 times higher what is possible to do with electrical stimulation in a safe way. A lot of model of chronic stroke in animal, and I'm talking about the work of Professor Ganguly. You heard this work yesterday by Eddie Chen, show that you need at least 4 volts per meter at cortical level to induce a change in a stroke model. We are 2 times higher what is needed for chronic stroke recovery. Are we able to target neural rhythm? Yes, we are, because we can do amplitude modulation of our E-field, and we can actually deliver the frequency at hertz level, also that the brain perceived. So we are okay with the key parameters, but how does it feel? And does it really work with stroke? Well, it doesn't feel like anything, so they don't feel anything in the patients. So if you think, if you can start the video, sorry. This is a video, but you think that is a picture because they don't feel anything. There is no peripheral stimulation. It's completely unsensation. And that we run a lot of participants, there is no side effect. KTMP has been approved as non-significant risk device. How does it work with stroke? Well, if there is a stroke with a motor impairment, with upper limb impairment, we are targeting the area that is perilesional, so that we can restore the neural network and we can restore the imbalance of the excitability. This is a patient on the left side before KTMP. You can see that fine movement are altered. You can really grab the ball. On the right side is after KTMP, 4 weeks. You can see how the fine movement are much better. And of course, this is proof with data that we can show. This is another patient, if you can start the video, sorry. On the left side is before KTMP. This is much more severe patients. Cannot open the hand. After 4 weeks of KTMP, 3 times a week, 20 minutes, if you can show the video, I'm sorry. You can see how we open the hands now. Now, the wrist is still spastic, but we target the hand motor area, not the wrist motor area. So, KTMP works, and we also tested, of course, in a scale that FDA like the Fugl-Meyer, and we call 6 patients, that's our pilot study, we call it a baseline, and after 4 weeks, and we tested to the upper limb extremity functionality with the Fugl-Meyer, and we see that after 4 weeks, nothing changed. Then we do 4 weeks of KTMP, and the improvement of the Fugl-Meyer. First of all, note that every patient improved, and this improvement is of 7 points and remain sustained for 4 weeks, at least what we have the data about now. Now, if you put this data in perspective, vagal nerve stimulation method that has been approved by the FDA in 2021, the improvement was 5 points. So we are in their scale. But if you read the clinical trial, 79% of their patients had side effect, and some also more severe adverse event. Now, when the stroke is in the cerebellum, what happened? That the patient can walk, lose the ability to balance and gait. So this is a video of my favorite patients in which we saw her at the beginning. She was not able to stand still. We tested to the ECAR, standardized scale. After 1 week of KTMP, look at her hands. She stands still. We called her back after 2 months because we wanted to have a shame control study. So we started with eye closed. Eye closed is more difficult, and she can't stay with eyes closed. She kept the ability to stay up with eyes open, but no eyes closed. Now, after 1 week of sham, KTMP, nothing changed. 1 week of active KTMP, look how relaxed her hands are. She can really stand, eyes closed. This is really what an impact has KTMP on the patient. She was able to dress herself, be more independent after KTMP. KTMP has been granted breakthrough device designation. That means that we are a promising innovation. There is no clear alternative existing for chronic stroke recovery. We are addressing an unmet need, and we offer a significant advantage over existing method. The path to regulatory is pursuing de novo approval as a class 2 device. We have 2 patents, UC Berkeley, but MagneticTides has an exclusive license agreement. We also and the first patent has been approved 2 weeks ago. So that's very nice. And then we have 3 provisional applications of KTMP through MagneticTides for translational application. KTMP project was awarded more than 15 million since the beginning of non-dilutive funding. We started in 2019 at UC Berkeley, where we built the first device with innovation grant. And then we realized how important is what we were doing. And so we formed the company, and we spin out in 2022 with a 3.5 million from NIH. And with this grant, we were able to build 2 more generations of the device and collecting pilot data in neurological patients, thanks also intramural grant. 2025, after the Brook designation and more patent, we got other 7.5 million from the NIH, and UC Berkeley, UCSF recognized the potential of the device, so they keep giving us intramural grant. We are starting a pivotal trial at UCSF in Professor Ganguly lab, and because of excellent results in our pilot study, we think that we need only 70 patients for the approval. We are, though, having a seed round. The exact amount will depend by what we decide with the FDA for the clinical trial. The idea is to accelerate the pivotal trial UCSF and to initiate commercial operation. The founder of MagneticTides, me included, are all UC Berkeley scientists. We have each of us more than 20 years of experience with non-invasive brain stimulation. I am a clinical neuropsychologist, so I work with stroke patients for a long time. Daniel Shelter is an MD with physics background and is the inventor of KTMP. Richard Ivey is an international recognized leader in neuroscience. We were working in his lab when we invented KTMP. We have 4 full-time employees, hiring 8 more professionals, and we have world-class collaborators. We are working at UCSF with Professor Ganguly for the clinical trial in stroke. We are working with Professor Andrew Crystal for exploratory trial in depression, in particular anhedonia. And this study is in collaboration also with Harvard, with Professor Buckner. We're working with Anel Petrevich at Duke University from the beginning of the project. Now is helping us developing coil that are specific for KTMP. The total addressable market for stroke motor recovery is 37 billion. Our target will be a private neuro rehab organization. The idea that we will help them to grow the revenue by increasing the charge for patient adding KTMP. We also want, of course, target integrated delivery network. We are starting with UCSF. The idea is that we will be able actually to make them reduce the cost because the effectiveness of the treatment. The business model will be a device lease model with a minimum payment for a month. All parties will be incentivized to adopt KTMP. Patients, fast recovery, no side effect. Practitioner, again, there is no better standard of care. And also the payer. We are definitely a cheaper option than the invasive one, where the cost will be lowering down for patients by 30K to 10, 15K. So we really believe that KTMP can make a difference for chronic stroke patients. We have very strong data in animal and in human. We have a clear path for regulatory and a clear economic. So thank you for your attention.
All right, thank you very much, Ludovica. I wanted to ask you a little bit about some of the history of neuromodulation efforts for stroke recovery. I mentioned in my talk yesterday about a company called North Star Neuroscience, which had a very promising cortical stimulation therapy for stroke recovery, raised a lot of money, went public, and then had a very famous failed pivotal trial. And of course, there were a few factors in that trial failure, but one of the big ones was just dosing, right? It turned out that everyone was dosed the same. I think they were trying to use 50% of motor threshold, but they weren't varying it. And so my question to you has to do with dosing. How do you determine dosing both for your trials and for the eventual therapy?
Sorry. You can do modeling, and basically we are approved to do 8 volts per meter, but the device is able to deliver much more high E field. So depending of the scalp thickness, all the characteristics of the patient, we will be able to assure that we're going to be around 8 volts per meter cortical level.
I mean, the key thing is in a clinical trial, you're not going to have subjects who just aren't getting the therapy, which was part of the problem in the North Star trial. You're going to make sure that everybody in the active group is getting the
Of course,
the therapy.
yeah, 100%. That will be the first thing.
All right, other questions for Ludovica? Anyone? All right, well, thank you very much.
Thank you.